Hello students, this is lecture number 9. In the previous lecture, we saw how to find the inverse of the matrix using adjoint method. Now, in this lecture we will study how to solve the system of simultaneous equation using the matrix method. Okay, so to solve the system of simultaneous linear equations, we need to consider a system of equations first. So that I will consider a system of equation which contains m equations, m number of equations, and n unknowns or variables. Okay, so that I will consider this system as, suppose, a11 x1, a12 x2, a13 x3 plus so on a1n xn is equal to, suppose, b1, where b1 is constant. Okay, and those values a11, a12, a13 up to a1n are the coefficients of the unknowns x1, x2, x3 up to xn. Okay, I will consider the second linear equation, that is a21 x1, a22 x2, a23 x3 plus so on a2n xn is equal to, suppose, b2. I will consider the third equation. Suppose this is a31 x1, a32 x2 plus a33 x3 plus so on plus a3n xn is equal to b3. Okay, and so on. I will consider the m equation. So this will be the mth equation, a1n x1, this will be a m1 x1, a m2 x2, a m3 x3 plus so on a mn xn is equal to b1, so that it contains m number of equations. Okay, so this will be called system of linear equation. This is system of linear equation, as it contains more than one equation. So what we will do, we will try and convert this system of linear equation into matrix form. Okay, so to convert the given system of linear equation into the matrix form, what we will do, we will consider the matrix. Okay, and the matrix will be like this. Okay, firstly we will consider the matrix of coefficients. Okay, and that matrix of coefficient will contain those terms a11, a12, a13 up to a1n. Okay, so this will be a11, a12, a13 so on up to a1n. Okay, then the second row will be a21, a22, a23 and so on up to a2n and so on. This will be a m1, a m2, a m3 so on. This will be up to a mn. So this will be the matrix of order m by n. Okay, into the matrix of unknowns, and unknowns will be x1, x2 up to xn. Okay, and this matrix will have the order n by 1 is equal to, this is a matrix of constant, which is b1, b2 up to bn. Okay, so this will be bn. Okay, so what we have done, we have converted this system of linear equation to matrix form. Okay, this is called matrix form of the linear system of equation. Okay, suppose I will consider this matrix as capital A, this matrix as capital X, and this matrix as capital B. So what we get? We get the system as AX is equal to B. Okay, where this A is called matrix of coefficients. Matrix of coefficients. This B is called matrix of constants, and this X, capital X, is called matrix of unknowns. Okay, unknowns or variables. Okay, so what we have done, we had one system of linear equation which contains m number of equations and n number of columns. So we converted that system of equations into the matrix form, so that we got the matrix of coefficient, matrix of constants, and matrix of unknowns. Okay, so in this topic what we will do, okay, so what we will do, okay, so we will try to find solution. Okay, solution means what? We will try to find this matrix B, that is to find matrix of unknowns. Okay, so in this topic we will try to find this matrix of unknowns. Means what? We will try to find this matrix of unknowns which will satisfy. So obviously this matrix of unknown will contain some number, and those numbers will be solution for our given system of linear equation. Okay, for example, suppose we have the system like this: x plus y minus z is equal to 1, x plus 2y minus 2z is equal to 3. Then this is suppose minus 2x plus y plus z is equal to suppose 4. Okay, so suppose I want to, okay, suppose question is convert given system to matrix form. So this is our question. So convert this given system to matrix form. Okay, so what we will do, firstly, for the conversion we will write the matrix of coefficient. Okay, so first row will contain the numbers like 1 1 minus 1, second row will contain the numbers like 1 2 minus 2, third row will contain the numbers like minus 2 1 1. Okay, into the matrix of unknowns. What are the unknowns here? X, y, and z is equal to matrix of constant, and constants are 1 3 and 4. Okay, so in this topic we have to find this matrix of unknowns, means to find the values for x, y, and z, so that those values of x, y, z will satisfy this system of equation. Okay, now question is how to find those values of x, y, z using matrix method. Okay, so we will see how to find this capital X using matrix method. Okay, so this should be our question. Okay, so to find the system, to find the value for capital X, or to find the matrix of unknowns, we need to consider our matrix, the system of linear equation into the matrix form. Okay, so we need this capital X, right? So we need this capital X. So what we will do, we will multiply both side by inverse of A. Okay, so what will happen? See this will be A inverse into AX is equal to A inverse into capital B. Okay, so after solving this will be like A inverse into A into X is equal to A inverse into B. Okay, now we know if you will multiply the matrix with its inverse. Okay, you may pre-multiply by inverse or post-multiply by inverse. Its answer always equal to identity matrix into X is equal to A inverse B, and again identity matrix into any matrix is equal to matrix itself. So this will be equal to A inverse into B. So this is how we can find this matrix of unknown X. Okay, so to find this matrix of unknown X, okay, we must know what is this value, okay, and what is this value. Okay, now what is this? This is the inverse of the matrix A, okay, and this is the matrix B which is given to us. Okay, so what we will do to find the matrix of unknowns, firstly by the given system of linear equation we will try and find the matrix of unknowns first using the matrix method. We know how to find the inverse of the matrix using the adjoint method. Then we will substitute that inverse of the matrix into this equation, okay, and we will get the matrix of unknowns, that is X. Okay, for example, suppose we have the system like this: x plus y is equal to suppose 1 and x minus y is equal to suppose 2. Okay, now question is find solution of system of linear equation. This system contains two equations and two unknowns. Find the solution for the given system using matrix method. Okay, now we know by matrix method, okay, what we have by Ax is equal to B, we can find this X, that is equal to A inverse into B. Okay, so we have this, so we will try to find the inverse of this matrix A. So that firstly you must know what is the matrix A. Okay, so from this system what we will do, we will try and write this system of linear equation into matrix form. So this will be matrix of coefficient, this will be matrix of unknowns, and this will be matrix of constants. Okay, so this is our matrix A, this is matrix X, and this is matrix B, and we have to find this matrix A, X. Okay, and this X will be given by A inverse into B. So we need to find the matrix A inverse. Okay, so by using adjoint method, the inverse of this matrix will be, okay, therefore by adjoint method, okay, we have seen this in the previous lecture. What is the inverse? A inverse is what? 1 upon determinant of A into adjoint of the matrix A. Okay, where this adjoint of A is nothing but this is what? Transpose of what? Cofactor matrix of A. Okay, so we will consider the cofactor matrix. Cofactor matrix of A is what? It is a 2 by 2 matrix. This will be A11, A12, A13, A21, A22. Okay, now we will find cofactor of every element, that is A11 and Aij, where Aij is what? -1 raised to I plus j into Mij, where Mij is the minor of the element A11. Okay, so we will write the matrix A. So let A is what? 1 1 1 minus 1. Okay, so we will find this first A11, which is -1 raised to 1 plus 1 into M11, where M11 is the minor of the element A11. Okay, so this will be -1 square into minor of the element A11 is what? -1. So finally this will be -1. Okay, so again A12 will be -1 raised to 1 plus 2 M12. Okay, -1 raised to 3 M12, and M12 is the minor of the element A12, and which is 1. Okay, so this is again -1. Again we can find this A13. There is no A13. This will be 2 1, so this will be minus 1 raised to 2 plus 1 m2 1. This will be minus 1 raised to 3 m2 1 is the minor of this element, okay, which is what again 1. Okay, so finally this will be minus 1. Okay, and finally we can find this a22, which is what minus 1 raised to 2 plus 2 into m2 2, so minus 1 raised to 4 into m2 2, so minor of this element 1 minus 1 is 1. Okay, so this will be again 1. Okay, therefore we got the matrix of cofactor of A is what minus 1 minus 1 minus 1 and 1. Okay, now we can find the adjoint of the matrix. Therefore adjoint of the matrix A is what 1 upon adjoint of the matrix A is what, it is a transpose of what, it is a transpose of cofactor matrix of A. So taking the transpose of the cofactor matrix, this will be minus 1 minus 1 minus 1 and 1. Okay, so finally we have got the adjoint of the matrix A. Now by adjoint method, what we know the inverse of the matrix is what 1 upon determinant of A into adjoint of A. Okay, now in this case we have got this value. Okay, so let's find out determinant of A. So determinant of A is what minus 1 minus 1, that is minus 2. Okay, therefore finally we get this inverse will be 1 upon minus 2 into the adjoint of A, which is minus 1 minus 1 minus 1 and 1. So finally we got this value for A inverse. Okay, so from the equation, okay, suppose I will say this equation as suppose star. Okay, so from equation star, what is x? X is A inverse into B. What is A inverse? Minus 1 by 2 into minus 1 minus 1 minus 1 and 1 into matrix B, and matrix B is 1 2. Okay, this will be 1 2. So let's multiply those two matrices, see what will happen. Okay, so this will be minus 1 into 1 will be minus 1, minus 1 into 2 will be plus 2. Okay, then again minus 1 into 1 will be minus 1, plus 1 into 2 will be 2. Okay, so this is equal to minus 1 by 2 into 1 1. Okay, so finally what we get x is equal to minus 1 by 2 into matrix 1 1, which is minus 1 by 2 minus 1 by 2. You can take this constant inside the matrix. Okay, so we know what is this x. This x is nothing but x and y. Okay, which is what minus 1 by 2 and minus 1 by 2, so that we get the value for x, which is minus 1 by 2, and value for y, which is again minus 1 by 2. So this is how we can solve the given system of linear equation using the matrix method. Okay, suppose I have this example which contains 3 equations and 3 unknowns. Okay, so this is our system of linear equation. Okay, and question is solve. Okay, solve means what? Find the values for x, y, z. Okay, means what? To find the matrix of unknowns. Okay, so we will convert given system of linear equation to matrix form. Okay, so convert this to matrix form. So what we will get, this will be matrix of coefficient. It will contains the coefficient of x, y and z. So first column will be 1 1 1, second column will be 1 2 4, third column will be 1 3 and 9. Okay, into the matrix of unknowns, this will be x, y, z equal to matrix of constants, that is 1 3 4 and 6. Okay, so finally what we have got, we got ax is equal to b, and what we need x, which will be a inverse into B. Okay, so this is our equation star. Okay, so from this equation star, okay, we will get the value for this matrix of unknowns using the inverse of the matrix and the matrix B. Okay, where by adjoint method, inverse of the matrix is what? 1 upon determinant of A into adjoint of the matrix A. Okay, so consider the matrix A. Consider the matrix A. Okay, this will be 1 1 1 1 2 4 1 3 9. Okay, so let's find out first determinant. Okay, this matrix should be, firstly it should be non-singular, means what? Its determinant should not be equal to 0, then only we will get the unique solution for this given system of linear equations. Okay, so find out the determinant of the matrix. The determinant will be 1 into 18 minus 12, okay, minus 1 into 9 minus 3, okay, plus 1 into 4 minus 2. Okay, so this will be 6. Okay, this will be minus into 6. Okay, and this will be 4 minus 2 is what? 2. So this will be plus 2. So finally we get this value for determinant of A, which is equal to 2, and it is not equal to 0. As it is not equal to 0, this implies what? The inverse of the matrix exists. Okay, now once you got this term, your next aim is to find out this term, that is the adjoint of the matrix A. Okay, and we know the adjoint of the matrix A is nothing but what? It is a transpose of cofactor matrix of A. Okay, so firstly we will write what is our matrix A. Okay, so matrix A is 1 1 1 1 2 4 and 1 3 9. Okay, so this is our matrix A. Okay, so we will find the adjoint of the matrix A. Okay, so what will be adjoint? Adjoint of the matrix A is what? It is a transpose of cofactor matrix of A. Okay, so let its cofactor matrix of A will be the 3 by 3 matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, so again one by one we have to find every value that is the cofactor of every element in the matrix A. Okay, so we will try and find every value for the cofactor matrix of A. Okay, so firstly we will find this A11. Okay, and this A11 is what? Minus 1 raised to 1 plus 1 into M11. Okay, so this will be minus 1 raised to 2 M11. Okay, M11 is what? It is a minor of the element A11. Okay, that is what? 2 3 4 9. Okay, so this will be 2 3 4 9, which is equal to 18 minus 12, which is equal to 6. Okay, so we got the value for A11. Next we will find A12, which is minus 1 raised to 1 plus 2 into M12, which is minus 1 raised to 3 into determinant, and determinant is the minor of the element A12, means minor of this element. Okay, so hide this row, this column. What remains? 1 3 1 9. Solving this will be minus 9 minus 3, which is what? Minus 6. Okay, now find out A13. A13 will be minus 1 raised to 1 plus 3 M13. Okay, so this will be minus 1 raised to 4 and into determinant, and this determinant is the minor of the element A13. So hide this row, this column. What remains? 1 2 1 4. Okay, so this is 1 2 1 4. Okay, minus 1 raised to 4 is 1, so this will be 4 minus 2, which is equal to 2. Now find out what is value for A13. A21 is what? minus 1 raised to 2 plus 1 into M21, which will be minus 1 raised to 3 into the determinant M21, that is a minor of this element A21. So head this row, this column, what remains? 1149. Okay, so 1149. Okay, so this will be minus into 9 minus 4, which is equal to 5, that is minus 5. Okay, now next is to find the element A22, which is what? minus 1 raised to 2 plus 2 M22, which is minus 1 raised to 4 into determinant M22, that is a minor of the element A22. Hide this row, this column, what remains? 1119. Okay, so this is 1119. So this is minus 1 raised to 4 is 1. So it will be 9 minus 1, which is 8. Fine. Now next is A23, which is minus 1 raised to 2 plus 3 M23. Okay, so this will be minus 1 raised to 5 into determinant, and determinant is the minor of the element A23, means of this element. So hide this row, this column, what remains? 1114. Okay, so here remains 1114. So this will be minus in bracket 4 minus 1, which will be minus 3. Okay, now the next element is A31, which is minus 1 raised to 3 plus 1 M31, which will be minus 1 raised to 4 and into determinant M31. So that will be the minor of this element. So hide this row, this column. So what we remains? 1123. Okay, 1123. So this will be 3 minus 2 is equal to 1. Next, find out A32. A32 will be minus 1 raised to 3 plus 2 M32, which is minus 1 raised to 5 into determinant, and this determinant will be minor of the element A32. So hide this row, this column. So what remains? 1113. Okay, 1113. Okay, so this will be minus 3 minus 1, which is minus 2. Okay, now next is to find A33. Okay, so which is minus 1 raised to 3 plus 3 into M33. Okay, so this will be minus 1 raised to 6 into the determinant M33. M33 is the minor of the element A33. So hide this row, this column, what remains? 1112. So this is 1112. Okay, so this will be 1. 2 minus 1 is equal to 1. So finally we got the cofactor matrix of A. Okay, and which will contain, the first row will be 6 minus 6 2. Okay, the second row will be minus 5, second row will be minus 5, then 8, and then minus 3. The third row will be 1, minus 2 and 1. So this is how we will get the matrix of cofactor of the matrix A. Okay, so this is our cofactor matrix. Okay, so after finding the matrix of cofactor, we can easily find the adjoint of the matrix A. Okay, and what is that? That is the matrix of cofactor and its transpose. Okay, so this will be equal to, just convert rows to the column. This will be 6 minus 6 2. This will be minus 5 8 and minus 3. This will be 1 minus 2 and 1. Okay, so once you will get the adjoint of the matrix A, you can easily find the inverse of the matrix. Therefore the inverse of the matrix is 1 upon determinant of A into adjoint of A. Okay, we calculated determinant of A is equal to 2 and into this adjoint of the matrix A, which is 6 minus 6 2, minus 5 8 minus 3, 1 minus 2 and 1. Okay, so we got this A inverse. Okay, now what, from equation star. Okay, so what is our equation star? The inverse of the matrix A, sorry, this matrix of unknown x is what? A inverse into B. So x will be A inverse. A inverse is 1 by 2 into 6 minus 5 1 minus 6 8 minus 2 2 minus 3 1 into B. Okay, and what is B? 3 4 6. Okay, and into this matrix B 3 4 and 6. Okay, so take this multiplication. The order of this matrix is 3 by 3 and the order of this matrix is 3 by 1. So matrix multiplication is possible. Okay, so let's take the multiplication. This will be 1 by 2 and whatever matrix we will get, its order will be 3 by 1. Okay, so this matrix will be of order 3 by 1, means it will contain 3 row and 1 column. So take down the matrix multiplication. This will be 18. Okay, 18 minus 20 plus 6. This will be minus 18 plus 32 minus 12. This will be 6 minus 12 plus 6. Okay, finally solving, this will be equal to 1 by 2 into, okay, 18 minus 20 is 2 plus 6 is 8. Okay, this will be minus 18 minus 30 minus 12, that will be 30, and this will be 2. Okay, and then this will be 6 minus 12 is minus 6 plus 6, this will be 0. Okay, so dividing by 2 to the given matrix, okay, then see what we will get. This will be equal to 4 1 0. Okay, and this is the matrix X. Okay, so we got the value for the matrix the value for the matrix X, okay, which is what? 4 1 0, and finally we can find X is equal to 4, Y equal to 1 and Z is equal to 0. Okay, so this is how we solve the system of linear equation using matrix method. Okay, this is a next example to solve this system of linear equation using matrix method. So what we will do, firstly again with the same process, what we will do, we will consider the given system into the matrix form. Okay, so convert to matrix form. Okay, so after conversion, what we will see, this will be the matrix of coefficient 1 1 1, this will be the matrix of coefficient 3 4 3, this will be in the third column 3 4 4. Okay, into matrix of unknowns, which is x, y and z, which is 12 15 and now 13. Okay, so this is how we can convert the given system of linear equation to the matrix form. Okay, so finally what we have got, Ax is equal to B, where A is a matrix of coefficient, X is a matrix of unknowns and B is the matrix of constant. Our aim is to find this matrix X, okay, and that will be given by A inverse into B. So that we need to find this matrix A inverse, okay, and that we will find using adjoint method. Okay, therefore by adjoint method, the inverse of the matrix is what? 1 upon determinant of A into adjoint of A. Okay, so firstly we will try and find what is the determinant of the matrix A. So firstly consider the matrix A. The matrix A is 1 1 1 3 4 3 3 4 4. Okay, so find out the determinant of the matrix, which will be 1 into, this will be 16 minus 12 minus 3 into 4 minus 4, okay, plus 3 into, this will be 3 minus 4. Okay, 16 minus 12 is 4, this will get cancelled, and this will be 3 into minus 1, that will be minus 3, and that is equal to 1. Okay, so finally we have got the determinant of the matrix, and this determinant is not equal to 0. This implies the inverse of the matrix exist. Okay, now what we will do, we will try and find the adjoint of the given matrix A, and we can find the adjoint of the matrix by finding its matrix of cofactors. Okay, so this is our matrix A, and what we need the adjoint of the matrix A. Okay, and that we will find using adjoint. This is what adjoint of A is. What it is? A transpose of cofactor matrix of A. Okay, so let's find out the cofactor matrix. So let cofactor matrix of A be what? A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, now find one by one every entry. Okay, where this Aij, we know what this is, -1 raised to I plus j into Mij. Okay, so firstly we will find what are the values for different Aij. Okay, so firstly we will find for A11, which is -1 raised to 1 plus 1 into M11. Okay, so this will be -1 square into determinant, and this determinant is what? Minor of the element A11, means of this element. So hide this row, this column. So what remains? 4, 4, 3, 4. Okay, so here it will be 4, 4, 3, 4. Okay, so which is equal to 16 minus 12, which is equal to 4. Okay, now next element, that is A12, which is -1 raised to 1 plus 2 into M12. Okay, so hide this will be minor of the element 3, that is A12. So hide this row, this column. What remains? 1, 4, 1, 4. Okay, so this is equal to -1 raised to 3, 1, 4, 1, 4. Okay, so this will be 4 minus 4, which is equal to 0. Now find out A13, so which is -1 raised to 1 plus 3 M13, which is -1 raised to 4 into determinant, and this determinant is the minor of the element A13 of this element. So hide this row, this column. What remains? 1, 4, 1, 3. Okay, so here 1, 4, 1, 3. Okay, so this will be 3 minus 4, which is equal to -1. Okay, now what we will do, we will try and find the next element. The next element is A21, which is -1 raised to 2 plus 1 M21. Okay, this will be -1 raised to 3, and this determinant will be the minor of the element A21. Okay, so hide this column, this row. What remains? 3, 3, 3, 4. Okay, so this is 3, 3, 3, 4. Okay, so this will be -12 minus 9, which is equal to -3. Okay, next element A22, which is -1 raised to 2 plus 2 M22, which is -1 raised to 4 into determinant. This determinant is the minor of the element A22. Okay, this is A22, this row, this column, 1, 3, 1, 4, which is 4 minus 3 is equal to 1. So this will be A23, this will be -1 raised to 2 plus 3 M23. So this will be -1 raised to 5 into determinant, and this will be minor of the element A23, means of this element. So hide this row, this column, 1, 3, 1, 3. Okay, so this will be 1, 3, 1, 3, which is 3 minus 3, which is 0. Okay, now the next entry, that is A31. This will be -1 raised to 3 plus 1 M31. This will be -1 raised to 4 into determinant M31. Okay, of this determinant. So hide this column, this row, 3, 3, 4, 4. Okay, so this will be 3, 3, 4, 4. Okay, this will be 12 minus 12 is equal to 0. Now next element is A32. This will be -1 raised to 3 plus 2 M32, which is -1 raised to 5 into determinant, and this determinant will be the minor of the element A32, means of this element. So hide this row, this column. What remains? 1, 3, 1, 4. Okay, so this is 1 3 1 4, so this will be minus 4 minus 3, which is minus 1. Now the next entry is A 3 3, which is minus 1 raised to 3 plus 3 M 3 3, so this will be minus 1 raised to 6 into determinant, and this determinant is the minor of this element A33. So hide this row, this column. What remains? 1 3 1 4. Okay, so finally we get this as 4 minus 3 is equal to 1. So finally we have got this matrix of cofactors. Okay, so cofactor matrix of A is what? Write down every element: 4 0 minus 1 first row, second row minus 3 1 0, third row 0 minus 1 1. Okay, 0 minus 1 1. Now after getting the matrix of cofactors, we can find the adjoint of the given matrix A, so that we can find the inverse of the matrix A. Okay, so this is our matrix of cofactor. Therefore we need this adjoint of A, and that is what? The matrix of cofactor of A into and its transpose. So this will be taking transpose, this will be 4 0 minus 1 minus 3 1 0 0 minus 1 1. So we got adjoint of the matrix A, so that we will get the matrix of inverse matrix, that is what? 1 upon determinant of A into adjoint of A. And if you'll observe, we calculated the inverse, and which is equal to 1. Okay, so no need to write. Okay, the determinant is 1, so this will be equal to 1 by 1 into the adjoint matrix, that is 4 0 minus 1 minus 3 1 0 0 minus 1 1. Okay, and finally we will get this matrix of constant unknowns A inverse into B. So A inverse is what? 4 0 minus 1 minus 3 1 0 0 minus 1 1 into matrix of unknowns, matrix of constants. Okay, and the constants are 12 15 and 13. Okay, this will be 12 15 and 13. Okay, so taking this multiplication, this is the order of this matrix is 3 by 3, and order of this matrix is 3 by 1. Okay, so number of column equal to number of rows. So matrix multiplication will exist, and whatever matrix we will get, its order will be 3 by 1. Okay, 3 by 1 means it will contain 3 rows and 1 column. Okay, so taking this multiplication of the matrix, okay, so this will be 48 minus 45 plus 0. Okay, then this will be 0 plus 15 minus 13, this will be minus 12 plus 0 plus 13, which is equal to 3 2 and then 1. Okay, so this is our matrix A. Therefore we got X is equal to 3, Y equal to 2 and Z is equal to 1. Okay, so this ends today's lecture. In the next lecture we will see what means the Cramer's rule. Okay, thank you.